In this video, we are going to discuss how to compare velocities of different objects rolling down an incline and how to use that velocity to determine who will arrive first at the bottom while rolling. So example 10.2 has a race down an incline where a solid sphere, a solid cylinder, and a hollow cylinder, which is basically a tube, all of the same mass m and same outer radius r, are released from rest at the top of an incline and they start rolling without sliding. In which order do they arrive at the bottom of the incline? So here we need to rank who will arrive first, second, and third at the bottom. And in order to determine that, you need to know the velocities of this object. Because the one which has the highest velocity will be the one to arrive first, and the one with the lowest velocity will arrive last. To determine these velocities, we are going to use the law of conservation of mechanical energy. And to apply this law, we will choose 2 points in motion. Let us select the top position and the bottom. We know from the law of conservation of mechanical energy, total mechanical energy at the top has to be equal to total mechanical energy at the bottom. Total mechanical energy is nothing but sum of kinetic energy plus potential energy. At the bottom, it will be the same kinetic plus potential. Kinetic energy at the top is zero because all objects are at rest on the top, so their kinetic energy will be zero. Potential energy at the bottom again will be zero because at the bottom they are not raised at any height, so they do not have gravitational potential energy. So you are left with potential energy at the top equals kinetic energy at the bottom. Now, since the objects are rolling, kinetic energy over here will be sum of two kinetic energy, translational and because of rotational motion. So I can write kinetic energy at the bottom as sum of translational kinetic energy plus rotational kinetic energy. Now let's substitute their rule. Potential energy at the top is gravitational potential energy. We write this as mgh. Translational kinetic energy will be half mv squared and rotational kinetic energy is half I omega squared. Now, I for each of these objects will be different, so we can just use the general rule for I, which is I equals CMR squared, and then compare the values of C later when we arrive at the rule for V. Omega I can write as V over R. So let's substitute these values over here. I write mgh equals half mv squared plus half. In place of I, we write CMR squared. Omega squared will be V squared over R squared. Now let's cancel off the common term. I can cancel M from each term over here. Then we can cancel R squared with R squared. And then rewrite whatever we are left with. We get GH to be equal to V squared by 2 plus CV squared by 2. Now we can take V squared by 2 common in both the terms here. So we can write GH to be equal to V squared by 2. We get 1 plus C. I need to find velocity, so we can rearrange the term to rewrite in terms of V squared. I will multiply with 2 and divide with 1 plus C. So we get 2GH over 1 plus C equals V squared. Now let's take square root on both sides to find velocity. So V becomes equal to square root 2GH over 1 plus C. Now, if you look at this expression, we get that V is inversely proportional to square root 1 plus C, or it is inversely proportional to C. That means higher the value of C, lower will be the velocity of the object, and smaller the value of C, higher will be the velocity of the object. So let us first compare the value of C for each of these objects. We know C for solid sphere is 2 over 5. C for solid cylinder is 1 over 2. And C for a hollow cylinder, which is a tube, is 1. It's nearly 1. And this is nothing but 0.4. For solid cylinder, it will be 0.5. And for hollow cylinder, it will be 1. And if you compare this value, you will see that C for solid sphere is smaller than C for solid cylinder, which is smaller than C for hollow cylinder. Velocity values will be opposite to this because velocity is inversely proportional to C. So velocity of solid sphere will be greater than velocity of solid cylinder, which is greater than velocity of hollow cylinder. So since the solid sphere has the highest velocity, it will arrive first, followed by the solid cylinder and then the hollow cylinder. So we can rank them as solid sphere being 1, solid cylinder being second, and hollow cylinder being third. So this is how you can compare the velocity values of different objects when they are rolling down an incline by just comparing the values of C. So if you get something like this in a multiple choice question, you can just remember that V is inversely proportional to square root 1 plus C. That means it is inversely proportional to C. And then compare the values of velocity to determine who will arrive first.